Well, this is now another section, just a reminder section called the trigonometric operation signs. We have the sine rule and the cosine rule, but then we have the ways of finding the various uh, sides of a right angle triangle, especially when you are given one side and one angle. So let's start with the right angle triangle when you've been given one side and one angle using the Sohcahtoa. So the other angle is always 90 degrees, by the way. So what we need to know is to label these sides. So we have a side here. This is right angle, 90 degrees. So when you have the 90 degrees, there is always a way of noting that this is the hypotenuse. This is the longest side. But now from there, we always have the hypotenuse, the adjacent, and the height. It depends on which side the angle is. So if the angle is in this side, because the height can be the opposite, or it can be the adjacent. So if your angle is on this side, this is where we have our angle theta. Then the angle that is just beneath it or beside it is called the adjacent angle. Automatically, the one which is opposite is called the opposite angle. So if you want to find this opposite angle, for this case, we have the sine rule. We have the sine for this one. We have the saw, which means the sine of an angle theta is given by the opposite of that angle divided by the hypotenuse. We have the cos, which is the car, which means that the cos of an angle theta, cosine, this is the cosine, which we just call it cos, of an angle theta is given by A adjacent divided by hypotenuse. And then we also have the last part, which is the torr. So which means that the tangent is given by opposite divided by adjacent. Well, so the condition that you need to choose on when you're using opposite and adjacent and hypotenuse depends with the question. Depends with the question. For example, the question, let's start with sine. Let's start with sine. Let's start with sine. So with sine, I mean saw. This is what I mean with sine, which is saw. So for saw, we mean if we have a right angled triangle, we've been given two sides. So we've been given, let's say, an angle here. We say this angle is, we are looking for two ways, the various way we can handle this. So the first one is we've been given an angle here, call it 60 degrees. Given 60 degrees, and we've been given only one side, which is hypotenuse. We've been given hypotenuse as 10 centimeters. So the question wants you to find the opposite side. They want you to find the opposite side. So they want you to find this side. They want you to find this side, AB. This AB that we are looking for should not be confused by AC, because we are looking for the opposite side. And we have the opposite, what we are looking for, and we have the hypotenuse given in the question. So it's only from the trigonometric sign, which is Sohcahtoa, the only trigonometric ratio that we are using for opposite and hypotenuse, it's only sine, because this is adjacent and hypotenuse and we need opposite. This is opposite and adjacent and we need opposite and hypotenuse. So for this case, we are going to use sine. So we say sine theta is equals to opposite over hypotenuse. It's not a must for you to say opposite. You can also say just over h. Now our sine angle is 60 degrees, so we can say sine 60 is equals to opposite, what we are looking for. We can call it x over hypotenuse, which is 10. That is what we are looking for. Therefore, to just find the value of x, we can just multiply this side by 10 and this side by 10. That means we are going to remove this. We are like solving the value of x. So x is going to be 10 sine 60. Going to be 10 sine 60. You just go to your calculator and just do 10 sine 60. Make sure your calculator is in degree mode. So make sure your calculator is in degree mode. It's going to give us something like that, which is 8.66. So I'm just going to use 8.7. So I'm going to use 8.7. So x is 8.7 centimeters. Now, suppose we are having something that is asking us to find maybe the angle. Assuming now we are looking for the angle, still in relation to the sine. Assuming now that we are looking for the angle, finishing with sine. We've been given two sides. One is opposite, one is hypotenuse. Remember, there are various ways you can have opposite. It's not a must for your angle to be at the bottom. So what if our angle is here? We are looking for the angle theta, yet we've been given this one as 3 and this one as 4. Whatever units they are. So we are looking for the angle theta. So we can remember we are looking for, no, I'm looking for one that we are going to use sine. So this is 3 and this is 5. Because we need opposite and hypotenuse. So for this case, for this to be our opposite, the angle, this is the opposite away, and then this is the hypotenuse. Hypotenuse is the longer side, and then the adjacent is just the side which is linking the hypotenuse and the angle. Now, because we are looking for the angle, we just need still to say that sine theta is equals to opposite over hypotenuse. Remember, our opposite is 3, so sine theta is going to be 3 over 5. So from there, what we just need to do, the opposite of sine theta is the sine inverse of theta. So for us to get theta, we have to take the sine inverse of this angle 3 over 5. So the sine inverse of 3 over 5, what is it from my calculator? You can also check from yours. So you just do the sine inverse. Sine inverse is the shift function of sine. That is sine inverse of 3 over 4. Now this is 5. And then you close the brackets. Well, we are closing the bigger bracket, not the smaller one. Find your answer as 36. Well, what was it? 36.87. So I'm putting it as 36.9 degrees. That's how you can find the value of these angles using sine. Now, let's check using cos. Still the side, and let's use cos. So we are checking at k, which is adjacent of hypotenuse. So we still have our right angled triangle here. So we still have this triangle. So I can put our angle theta here today. And this one is x. So we are looking for x today. And let's put our theta as 50 degrees. So we are looking for x. Remember, we have two sides. We have the hypotenuse and we have the adjacent. We don't have the opposite. From the relationship, the only place that we have adjacent and hypotenuse is from Ka. Sohcahtoa, this one is indeed having the hypotenuse, but it's missing the adjacent. It has the opposite, so we don't need it. This one is having the adjacent indeed, but this one is the opposite, which we don't need it. So we're remaining with cos. So we can say the cos theta is equals to, that is Ka A over H. Remember, all of them is S O over H, Ka C A over H, and then tau, which is T O over A. So those are their relationships, those are their ratios. So we can say that the cos of theta, cos 50, is equal to, now adjacent is 8 and hypotenuse is x. So we are looking for x. It's got the long way, the long method possible. So the first thing, we can multiply both sides by x, this by x. So we are going to have x cos 50 degrees is equals to 8. And then from there we divide both sides by cos 50. So we just need to remain with x. So x is equals to 8 divided by cos 50. And just press it that way. 8 divided by the cos of 50. 8 over cos 50. It's going to give you 12.44. So I'm just going to put it as 12.4. 12.4, I'm assuming it was in centimeters. 12.4 centimeters. The same way, if you want to find the angle, use the same way, just make sure that the angle is the theta. Like if you want to find the 50, like make sure that what you are looking for is theta. What I mean by what you're looking for is theta, just say that cos theta is equals to adjacent, assuming now that our adjacent, we got it, we still had 8, and hypotenuse was 12.4. So you just have to find the cos inverse of this value, because 8 over 12.4, just have to find the cos inverse of 8 over 12.4. And you have your answer, of which if you do the same, let's do it here. So this is our answer, 12.4. So I'm just going to do 12 divided by answer, 8 divided by the answer. That is it. And then I'm going to do the cos inverse of this, cos inverse of the answer, which gives me perfectly 50 degrees. So for the tan, you have your right angle triangle here. So you have something like 3 here, and you have x here, and you have an angle 30 degrees. So to find x, you just say tau. This the only means, these are the two links that you need. So you can say tan theta, which is 30, is equals to opposite, which is 3, over adjacent, which is x. So to find x, by the rule, you're just going to have 3 over tan 30. So which you're going to press here as 3 over tan 30. And you're going to have your answer that way as 5.1. So you're going to have it as 5.1 centimeters. As simple as that. Those are the trigonometric sign. Practice more of them. Thank you very much. Enjoy mathematics.